Okay, so now we just got a bunch of right triangle problems. There's going to be 5 problems remaining. And before we get started, analyze angle measures, all right? And why, we'll talk about that when we cross that road. But here we have 40 degrees, cool, okay. 40 degrees, we don't really know anything cool about triangles with 40 degrees. We know this is the adjacent side, the height of the lamppost that we want to find. So approximately how many feet is the street light? We're going to round our answer to the nearest hundredth. This says H, but it's actually the opposite side. So again, maybe you're also going to write so, Gatoa. All right, now thinking which trig function uses opposite and adjacent? Well, that's TOA. Tangent is opposite over adjacent, so Gatoa. So tan of 40 degrees is going to be the opposite over adjacent. So let's actually plug in numbers. And then tan 40 is just some number. So put that over 1, cross multiply. We get the opposite side equals 20 times tan 40, which is about 16.78. Again, rounding to the nearest hundredth, it's a good habit to read the directions and answer the question. A triangle is shown. What is the length in inches of side A? So, something we have to immediately notice is this is a 30-degree angle, so this is a 60-degree angle. So I purposely randomly put this problem in here because then now we have to recall 30, 60, 90. So yes, we can use trig for this and we would still get the correct answer, but there's also times where we can use 30, 60, 90s and get the most accurate answers. All right, so this is given the hypotenuse is 44. We need the short leg and the long leg. And again, students struggle with 30, 60, 90, and 45, 45, 90 triangles. They struggle with these right triangles when they don't memorize the rules. If you memorize the rules and know how to go about it, these problems are incredibly easy, such that the short leg of a 30, 60, 90 is half the length of the hypotenuse. So we just divided by 2. What's the long leg? It didn't ask us to, but we can do it for fun. You just multiply by radical 3, and the long leg is 22 radical 3. All right, so students just want to either do special rights or trig. They don't like to do both, but you got to remember, sometimes you got to use one or the other. All right, don't forget about that. So now looking at this one right here, what is the approximate height in feet of the tree in the figure below? Well, this is a 50-degree angle. We don't know anything about that. That's not a 30, 60, 90. It's not 45, 45, 90. It's a 50-degree triangle or a 50-degree angle. So we're going to have to use trig. So based off this, we need the height of the tree, which is the opposite, and then that's the hypotenuse. So now thinking, which trig function uses opposite and hypotenuse? Well, that's so. So and SOHCAHTOA uses that. So it's going to be sine theta equals opposite over hypotenuse. Now between theta and my cursive O, notice that one has a really big tail, the other one doesn't. That's how I try to differentiate. Then we're just going to put sine 50 over 1 and cross multiply. And we're going to get cursive O, the opposite side equals 100 sine 50. And 100 sine 50, plugging that into a calculator, 76.6. And then this one right here, the triangle has in dimensions shown what is exact and approximate area of the triangle. So what does this mean right here? Well, first off, press pause. We got a 30-degree angle again. So this is a 30, 60, 90. And again, it's about just memorizing the rules. If you need to Google them, rewatch the videos, refresh your brain, whatever you have to do. But this is the hypotenuse. So we need the short leg and long leg. So again, same rules as above. Hopefully this doesn't seem too foreign to you. Got to divide both sides by 2, so the short leg is 4. Then to get to the long leg, yes, we can use Pythagorean theorem, or we can just utilize these rules. It's multiplied by radical 3. So the long leg is 4 radical 3. All right, Now it said find the area exact and approximate. This is why special rights is so powerful. It gives us exact answers. The exact area of this triangle is 1/2 times the base 4 times the height 4 radical 3. And you're just going to do 1/2 times 4 times 4, which spits out 8. If you multiply all those numbers together, then radical 3. All right, rounded, yeah, we could have used trig. Or I can just now plug this into a calculator, and 8 radical 3 into a calculator is about 13.86. All right, so that's how you do that problem. And then last one is, what is the value of x in the triangle below? So yeah, we can use trig. That's mathematically legal. Or something else we can notice is, well, this is x and x makes this an isosceles, so these two angles must be the same, so in fact they both must be 45 degrees. All right. Well, then this means it's a 45, 45, 90 triangle, so now I can implement the rules, and rather than use trig, there's two ways to think about it. I can either think I can divide both sides by radical 2 or multiply by radical 2 over 2. Remember, they're the same rule. It's the same thing, just one has a rationalized denominator. In this case right here, I'm going to just multiply by radical 2 over 2, because then 10 times radical 2 over 2 is going to simplify really nice into 5 radical 2. And that is also this x over here because it's an isosceles triangle. All right, so that's it. Hopefully you had fun and